Alright, hello everyone. Today we're going to be looking at a thermal energy concept called latent heat. Now, specific latent heat is something that you need to be able to describe and also solve problems with. Now we'll go through what it actually means in this video, and then we'll go through some problems in a future video. So if we have a look at this graph here, sort of what's going on here is, imagine we have a container or a pot. Let's go with a pot of water on a stove. Okay, and it is being heated from a plate underneath. Right now, the y-axis on this graph, that represents the temperature, the change in temperature of the water. So you can see here, well, let's say that the water actually starts off, it's frozen, right? So we have an ice cube, for example, this water in here, and the pot might be frozen to start off with, and then we start to heat it up. And we heat it up when it gets to 0 degrees. Now everyone knows that the melting point of water is 0 degrees. So at this point here, the water starts to melt. Now, at a point where the water is melting, we can see that we're still adding energy into the system. So we don't stop heating the water. The water is still being heated at this point here, but the temperature isn't changing. So we have an increase in energy, thermal energy, but the temperature is constant. So what's happening? Where's the energy going? If the energy is not going into the system to make the particles move faster, to increase the kinetic energy, then where is it going? Well, the energy is actually going into the bonds in between the atoms. So remember back to grade 10 and grade 9, even before that, when we learned about the structure of solids and liquids. Solids are packed together quite tightly, and then liquids, the molecules are a little bit further apart, and then with gases, the molecules are very far apart. So they're kind of spaced differently and not as close together in gases compared to solids. So there has to be energy coming into the system. Energy needs to be brought into the system to sort of, you can think of it as pulling these bonds apart or separating the bonds. So that point where those bonds are being separated by the energy added is represented by this section of the graph here. So that there, Q2, is called the latent heat of fusion. And that just represents the energy required to undergo a phase change for the solid to become a liquid. And the energy isn't going into becoming, isn't increasing the kinetic energy. So the particles aren't moving any faster when we add temperature, but instead the particles are being separated apart in the solid to become a liquid. All right, so over here, the water is ice, and over here, the water is liquid, and over here, the water is steam. And the sections in between these flat regions, temperature is constant, but we're still adding energy, thermal energy, to break apart those bonds in between the atoms. Okay, so these plateau regions are called the it's a specific latent heat. So this is called the latent heat of vaporization. specific latent energy of vaporization and specific latent energy of fusion, or specific latent heat. And we'll go through how to solve that. Actually, we'll go through now how to solve those ones as well. So Q equals ml. That's it. Q equals ml. Now, it can be LV or it can be LF. Now, that just depends on whether it's latent heat of vaporization, whether we're talking about this one here, or latent heat of fusion, which is this one here. Now, you'll be given the latent heat of fusion and latent heat of vaporization in your question. So you'll be given this one here. And then you just need to know the mass to calculate the Q value, which represents the energy added to the system to go from a solid to liquid or liquid to gas. Okay. That's a pretty quick summary of latent heat.